Let's keep moving along. This one is ray tracing. And we're going to do a concave mirror. And we're going to put the object outside the focal length. Alright, for a concave mirror, again, the shape of our mirror is going to be really important, but I want to start off with just kind of this idea. I have a concave mirror, looks like this. It's mirrored on the one side, so if I have a line coming through the middle of it and I place my object over here, even without an object, if I start looking at parallel rays coming in, a parallel ray here will bounce down this way. A parallel ray here will bounce down this way, and you start to see what's going on. A parallel ray here bounces out this way, and what we get is a focal point over here. We're going to get a real focal point. So we do, again, need to be pretty careful about the shape of these things, but the focal point is going to be outside of the mirror. The mirror itself would be, like this kind of a thing. So let's get to that. Again, because the shape is going to be important, I'm going to make this shape separately and then import it into here. So I'll move the screen, and the next time it pops up, there will be a shape. Okay, I have a big spherical mirror, and I'm going to draw my axis here. This location is my focal point, and I'm going to have a focal length of 24 centimeters. I would like to have an object distance. I'm going to keep my object small, but I'm going to put my object right here. At this location. So my D object is 40 centimeters. My H object is 2 centimeters. And let's see what I can do with these rays. Ray 1 is going to go parallel to my axis and then through the focal point. So I'm going to go parallel to my axis and then through the focal point. And that's like that. Ray 2, that was ray 1. Ray 2 is going to do the opposite. It's going to go through my primed focal point and then parallel to the axis, but my primed focal point is the same as my regular focal point because I'm looking at a mirror. So through this, gets me here, and then parallel to the axis. Has me moving along this line. There is ray 2, ray 1. These two, they cross right here. And I get my image. My image distance is 60 centimeters. My image height is negative because it's upside down, and that looks like 3 centimeters. And now I'll turn off the background dots and we'll take a look. So I found my image. This was my object over here. And I'm going to do my magnification calculations. Magnification HI over HO is negative 3 centimeters over 2 centimeters gives me a negative 1.5 for my magnification. I want to check it against the other version, negative DI over DO. So negative of 60 centimeters over 40 centimeters is negative 1.5, and that does check out. So this is the image formation by a concave mirror for an object outside the focal length. The reason that I made this object so small is that because of the curvature of this mirror, we do start to run into some difficulties on just where it is that we're striking by making this small relative to the size of the mirror. It was going to be pretty easy to see what was going on.